of manufacturing, of producing 200 yards of fabric. This is it. So the definite integral, if we are given the derivative function, which is the marginal cost, the integral, integrating this function, this derivative, as a definite integral, because this is a continuous function. This is continuous. I didn't say that because I cannot determine a definite integral from a function that is not continuous on this interval, but it is. It's a linear function. So this is continuous. I can determine the definite integral. I find the antiderivative, and then I evaluate it from 0 to 200. In the function, I plug in 200, and I subtract. When in the function, I plug in 0. But because in this example, this number was 0, I omitted it. But you have to be careful. This is not always 0. So we got this. And this was our cost. Okay. Let's also look at 37 on the same page. So they're given some fitness company has found that its marginal profit in cents, okay, fine, is given by negative 0.1236x cubed plus 0.28x squared plus 55.6x for any x less than or equal to 500, where x is the number of members. X, number of members. Currently enrolled at the health club. Approximate, I'm showing you the book, but I also printed it out. It says, approximate a total profit when 300 members, 0 to 300, when 300 members are enrolled. Of course, they're giving us how, and we know x, delta x is 50. And I printed it out, so then I can show it. So approximate a total profit when 300 members are enrolled. We know now how to determine the exact. We know how. How do we determine the exact profit for 300 members? Can anyone help us? And then we'll look at what they are asking. But what will the exact profit be?
Would it be sigma?
The definite.
Yeah, sorry.
Definite integral.
To,
they say 300 members.
Yeah.
From p prime of x dx. We can determine this exactly. We put in the function, we find the antiderivative, and we plug in 300 and we subtract when we plug in 0. So we know how to do this. However, they are asking us to estimate from 0 to 300 members, and they're telling us that delta x is 50. Okay, so are they asking us to use the leftmost point or the rightmost point based on the graph?
The rightmost?
Of course. Of course. I'm sorry, the leftmost point, not the right. Sorry.
Can you explain why real quick?
Yes. See, this piece stops here. It's not here. It's not this, but it's this. So its height is here. The height of this one is here. The height of the next one is here. The height of the next one is here. And the height of the next one is here. And where is the first one? Here. Here how it will look, this is how it would look like with the rightmost point. because I'm using this height for this rectangle. I'm using this height for this rectangle. I'm using this height for this rectangle. I'm using this height for this rectangle, and so on and so forth. So the height is on the right. But in our example, the height is on the left. Is that clear? So it's the leftmost point. Okay, so for the area with left 6 is approximately, of course, delta x is the same, so I have 50. And I have f of 0 plus f of 50 plus f of 100 plus f, so this was 50, 100, 150, 250. Okay, so f of 100, f of 150 plus f of 200 and plus f of 250. So remember, I have to have 6. If you go to the last one, then that's wrong. So 1, 2, 3, 4, 5, 6. Stop. If I want the right one, 1, 2, 3, 4, 5, 6. So now in the given function, I have to plug these values in and multiply by 50. So let's do this with the graphing calculator. I highly recommend the steps that I show you. It's up to you, however. You have other options.
Professor?
Yes, I'm ready. Yep.
So for this kind of problem, you wouldn't need to find the antiderivative to approximate?
If they say approximate, no.
Okay.
The total profit with when 300 members are enrolled by computing blah, 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 blah. Good. So let me show you what I recommend. In the list, edit, highlight list L1, clear, highlight the top of list L2, clear, and enter. And now I enter these numbers. There are 6 numbers. I don't really have to enter 0 because it will be 0. So I'm going to skip. I'm going to enter 5 numbers. So 50. Because the function, let me look at the function one more time. The function, I didn't copy it, but I did on this page. As you see, the function, when you plug in 0, it will be 0. So 50, 100, and 150, and 200. Otherwise, everything has to be there, and 250. So now highlight list L2 and enter, while highlighting just the top, enter this, 50, parentheses, and now the function, negative 0.00, there are 3 zeros, 06, and now x, but x is in list L1 to power 3. And then come down from there, plus 0.28. Now x, but that is in list L1, and I want it squared. And then plus 55.6 times x, but x is list L1. And close the parenthesis. And when you click enter, all these numbers will pop up in a blink. And now all we have to do is just go to stats again, and this time we calculate, and we want one variable stats on list L2 and calculate. This is all I need. The summation notation, not this, nothing matters here, just the sum. So the sum is 3,166,250. So that's our approximation. 3,166,250.
Sorry, how did you get the 1-bar stats?
Back to stats and calculations this time. Not edit, but calculations. And choose the top one, one variable stats, and make sure you have list L2 in there. And calculate. And that is the summation notation we need, the sigma notation that we learned at the beginning of this chapter. Okay, of course, this is in dollars. Don't forget the measurement unit. So the area is the total profit, approximated. Okay. Any questions on this? So this was total profit. I'm going to post this as well. Of course, you can check by calculating the exact profit if that's what you want. Okay. So now I consider 4.2 finished as well. So let's see the leftovers from 4.3. Okay, from 4.3, I also printed out some of the problems so I can explain easier. So on page 413, and these problems, and I let you choose, find the area under the given curve over the indicated interval. So let's choose. We either want to determine this area, or we want to determine this area, or we want to determine the shaded areas. Choose one. And then I'd like to discuss what this means, for example. So this is number of units produced, and this is marginal revenue in dollars per unit. Of course, marginal revenue has two measurement units, dollars per unit. What will this represent? Of course, the total revenue. So this is total revenue on this interval. So this area, once we determine the integral from 0 to this, from the marginal revenue, this will be the total revenue between 0 and x. What will this be? Sales on the 10th day, whatever. So what will this be? Total sales between this and this, all this area. Once we integrate this function from 0 to this, then we will get a number, and this will be the total sales for these number of days between this and this. Okay, so now let's choose one and determine the area. And then I have other examples. Or if you want to choose from here, it's up to you. They're the same. This is a little bit easier, only because it's just on one side. But here we can discuss this. See, this is a positive area. It's above. And this is a negative area. So when I add them up, obviously the area will end up being positive because this piece is bigger than this piece. Here the area will be negative because it's entirely under the x-axis. Entire negative. Here, I don't know, it appears that this is positive and this is negative and they appear to be equal. So the area should be 0 if they are equal. I don't know, we'll see. And here, I'm not really sure. This is positive, of course, and this is negative, but I can't really tell which one is bigger. I think that this is bigger than this, but I can't be certain. So areas can be negative. That was my point here so far. Would you like to choose, or I will?
We do number 7.
Okay, this is number 7. In number 7, we have the integral from 0 to 2 from x cubed dx. Good, that's all. Which function prime is x cubed?
over 4.
That's it. From 0 to 2. Luckily, when I plug in 0, it's going to be 0. So I only need to plug in 2. 2 to the 4th is 16. 16 over 4 is 4. So if you want, this is 4 units squared, whatever the units are. Good. Let's also choose from here.
We do 38.
38, this one?
Yes.
Okay. So we have in 38, we have the integral from 0 to b from negative 2 e to 3x dx. Perfect. Okay. Of course, negative 2 is a factor that comes out. So now we're asking ourselves, what function prime is e to 3x? From 0 to b.
Would be e to 3x divided by 3.
Thank you very much. Awesome. So then I have negative 2/3 in front, and I have e to 3x from 0 to b. So negative 2/3. I plug in b and subtract. Careful, because this is not 0. E to 0, 0 times 3 is 0, but this is 1. Do not disregard e. So this is negative 2/3 e to 3b minus 1. And that's it. I'd like to evaluate one more and then we continue, like 55. And that we're given the integral, no graph, this is just an integral. X plus 1 over x dx. I didn't check whether this function is continuous because this function is continuous on any interval. Here, this function will not be continuous and x equals 0, but 0 is not in the interval. So I checked. It's continuous. There. Okay, perfect. So now let's start. What function prime is x? No, you already told me that. It's x squared over 2. And now plus. What function prime is 1 over x?
Natural.
Excellent. Of the absolute value of x. Awesome. Thank you very much. It's the only one. 1 to e. I plug in e. E squared over 2 plus, how much is natural log e?
One.
Thank you very much. Minus, be very careful. Careful, because if you do not distribute the negative sign to both terms, the answer will be incorrect. So very careful on that.